Alright guys, we're going to start looking at the second page of your notes now. So, you should be on this page that looks like this, page 2. We're going to look at functions in vertex form, how we can get the graphs from the equation, and how, when we change the different values in that function, what it affects on the graph. Remember, vertex form is a times x minus h squared plus k. The important part to remember is that minus h inside the parentheses. The minus h means that when I go to write the vertex of this, because it is negative h and my vertex is the point hk, I'm going to change the sign of the number inside the parentheses, and that will give me my x value of my vertex. The plus k at the end, because it's a positive, I can keep that sign, and that will give me my y value of my vertex. So, when I look at this first example we have, y equals x minus 1 squared plus 3, the negative 1 inside tells me that when I go to write the vertex, I have to change the sign of the number inside. So negative 1 will become positive 1. And the number outside, I'm going to keep the sign, and that's going to be my y value, so 3. That's my new vertex. So my new vertex is the point 1, 3. I'm going to start by putting that on my graph, because we're going to use that to find the other points for my graph and to graph it. So the point 1, 3 tells me I'm going to start at the origin, and I'm going to go to the right 1 and up 3. There's my new vertex. Now, I'm going to use the vertex and the key points to graph the function. By key points, we mean the table for the parent function. So if you remember, our parent function was y equals x squared. So I'm going to write that table now. X and y, and I had x values of negative 2, negative 1, 0, 1, and 2. My y values, when I plugged them in, the x values in, gave me 4, 1, 0, 1, and 4. This is what we consider our key points, or our table for our parent function. We're going to use this table for all of these examples to figure out what's being done or what's happening to the parent function. And the way we do that is we start by looking at the vertex. The vertex of my parent function is the point 0, 0. So if I look at my vertex from my parent function vertex was here at 0, 0. To get from my parent function vertex to the vertex of my new equation, I went to the right 1 space and up 1, 2, 3 spaces. So the parent function shifted 1 unit right and 3 units up. So that's my answer to part C. Describe the transformation of the parent function. The parent function is going to move 1 unit to the right and 3 units up. So every point on that parent function has to move the same distance. So if I look, I started at negative 2, 4 with my first point. So that's negative 2, 4 is right here. I'm going to take that point, I'm going to move it 1 point to the right, or 1 space to the right, and up 1, 2, 3 spaces. So my new point is here at negative 1, positive 7. I then had negative 1, 1. So negative 1, 1 is here. I'm going to do the same thing. To the right 1 and up 1, 2, 3 spaces. Then I have 0, 0. We've already moved. That's my vertex. So my next point was 1, 1. So here's 1, 1. I'm going to move it to the right 1 and up 1, 2, 3 spaces. That becomes the point 2, 4. Then I had the point 2, 4. I'm going to move that to the right 1 and up 1, 2, 3 spaces. That's here. So my new graph is right here. So if I were to graph my parent function, negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4, the whole graph, when I look at it compared to the parent function, my blue function is my new function, my red function is my parent function, the whole graph, every point on it moved left 1 and up 3. Or right 1 and up 3, sorry. So if I look at this in comparison to the points, my new graph, my chart here, for my new function, my new graph, I have the point negative 1, positive 7, negative, or 0, 4, 1, 3, 2, 4, and 3, 7 for my new points. So if I look at it, if I wanted to do this another way, what I could do is I could look and I could say, all right, what happened to the vertex? It was 0, 0, it became 1, 3. So my x value, I added 1. My y value, I added 3. So if I go through from my parent function and do the same thing to each of these y values, negative 2 plus 1 is negative 1. 4 plus 3 is 7. Negative 1 plus 1 is 0. 1 plus 3 is 4. And so on. I can get this chart. So let's look at another example of this. If I'm looking at number 5, I have f of x equals x squared minus 2. This, the way it's written, is in standard form, but it's not the way we recognize standard form. So because I don't have the parentheses here, what I can do is I can rewrite this as x in parentheses squared minus 2. Then I'm missing a term. I'm missing the number being added to or subtracted from the x. So I'm going to add in a number. And remember that when I add in a number, we call that a placeholder for a missing number. And anytime I add a placeholder, I add 0. So when I look at this problem, I have x plus 0 squared minus 2 when I add that placeholder in for the missing number with the x. So again, I'm going to take what's inside, I'm going to change its sign. Positive 0 would become negative 0, but since 0 is neither positive nor negative, I can just leave it 0. Keep the sign of what's outside, negative 2. So my new vertex is the point 0, negative 2. I put that at the wrong spot here, down here, 0, negative 2. Now, again, I'm going to start by looking at my parent function, y equals x squared. And every time it's the same. My x values are negative 2, negative 1, 0, 1, and 2. My y values are 4, 1, 0, 1, and 4. So always, what I'm looking at is this. My vertex was 0, 0. So that was right here. There are two ways I can do this. The first would be to take each one of these points, go onto the graph, and move it. The other way is to write a new chart for my function, x and y. In the middle, I'm going to make the middle value in my chart my vertex. 0, 0 was my vertex. Now it becomes 0, negative 2. So if I look at this, 0, 0 changed to 0, negative 2. So the x value didn't change. So for my new function, none of my x values are going to change. So I can bring those over the way they are. Negative 2, negative 1, 1, and 2. My y value changed. It went from 0 to negative 2. So 0 to negative 2, you subtract 2. So from each of these y values I have here, I'm also going to subtract 2. So 4 minus 2 is 2. 1 minus 2 is negative 1. 0 minus 2 was negative 2. That's how we figured that out. 1 minus 2 is negative 1 again. And 4 minus 2 is 2. I now have my chart for this function, so I can graph it. I'm going to graph that function. So I have negative 2, positive 2. So negative 2, positive 2 right here. Negative 1 here. 0, negative 2 we already put on the graph. 1, negative 1, and 2, 2. This is my new function. Now again, if I wanted to compare it to the parent function, I could graph this y equals x squared function. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4 are right here. When I look at that, and I want to compare it, each point on the parent function moved the same direction in the same number of spaces. Each of the points on the parent function shifted down 2 spaces or units. Most of the time you'll see it called units on a test. So what I'm looking at is this whole graph, this red graph, the parent function, every single point on it moved down 2 spaces. All right, let's take a look at number 6.